I want to extend this idea of finding the difference between 2 points to calculating the slope of a line using the coordinates of 2 points that are on that line and its related slope triangle. I'm going to use these same 2 points. Here's the positive 12 and here's the negative 4. And the distance between them are these positive 16 units. So here's the positive 12. So this is 12 units along the x-axis. This is the x-coordinate, positive 12. And here's the negative 4. This is negative 4 units along the x-axis. So this is the x-coordinate, negative 4. And you first learned about the slantedness of this line, or the slope of this line, in lesson 10 of unit 2. And at that time, you learned about its related slope triangle. Here's the related slope triangle, and the slope is a calculation of the length along the vertical axis, this length right here, compared to the length along the horizontal axis, this length right here. The slope tells you how many times this vertical length is compared to the horizontal length. Sometimes the slope will be a fraction less than 1, so that means that this vertical length is a fraction of this horizontal length, is less than the horizontal length. So this is not very slanted. Other times the slope will be greater than 1. So that means that this vertical length will be longer than the horizontal length. So this slantedness will be greater. It will be pushed up so that this vertical length is greater than the horizontal length. And the slope is greater than 1. When you calculate the slope of this line, you calculate the difference between the x-coordinates, so this 12 and this negative 4, this 12 and this negative 4, and the difference between the y-coordinates, this positive 5, this negative 3, which is this positive 5 right here, and this negative 3 right here. When you calculate that difference, what you are doing is moving this vertex of this slope triangle right here to the origin. When you do that, then the coordinates of the slope triangle slide over, and when you read them, when you look at them, they are the horizontal length and the vertical length of the slope triangle. And it's that ratio, the vertical length to the horizontal length, that is the slope. So we know that the difference between this positive 12 and this negative 4 is a positive 16 units. When we make that calculation, we're going to slide this slope triangle. So one way to make that calculation is to add positive 4 units. So add these positive 4 units right here to this triangle on the other side. So I'm going to slide it over. So you can look at it as taking away these 4 units and sliding this triangle over, or adding these 4 units onto this side over here. So this length is 16 units along the x-axis. It is the horizontal length of that slope triangle. And then when you calculate the vertical length, that's the length along this side. So when you make that calculation, you're going to slide this slope triangle up 3 units. You're going to take away these negative 3 units or add a positive 3 units to that. So you're going to either take away the negative 3 units or add positive 3 units. So this length is going to be 8 units. Positive 5 and negative 3 are a positive 8 units apart. So this slope triangle is going to slide up these 3 units. So this whole blue triangle now is the same triangle. It's just slid over so that this vertex is right at the origin. And so the x-coordinate is the length along the horizontal side, and the y-coordinate is the length along the vertical side. So here are these 8 units. So this triangle is sliding up 3 units. So this total length right here is 8 units. And so that relationship between the length along the y-axis compared to the length along the x-axis is 8 to 16, or 1/2. So that tells you that this vertical length is 1/2 as long as the horizontal length. So for every 2 units along the horizontal axis, this line goes up 1 unit along the vertical axis. So 2 units up 1 unit, 2 units up 1 unit, 2 units up 1 unit. That is the same as for every 1 unit along the horizontal axis, the vertical length is 1/2 unit. So this is 1 unit, 1/2 unit, 1 unit, 1/2 unit, 1 unit, 1/2 unit. So to calculate the slope of this line, you figure out what the difference is of the x-coordinates, this positive 12 and this negative 4. So that's sliding the slope triangle over to the right in the horizontal direction. And what's the difference between the y-coordinates, this positive 5, and this negative 3, and that's sliding the slope triangle in the vertical direction. And that ratio, which is going to be 8/16, is the slope. It's 8/16, or it's 1/2, which tells you that this length right here is half as long as this horizontal length right here. And that determines how slanted this line is, or what is the slope of this line.